Welcome to this deep dive presented by Bota-Labo. Today, we're digging into IonQ's acquisition of SkyWater Technology. Now, this isn't just another corporate merger. Make no mistake, this is a landmark deal, and it signals a fundamental shift for the entire quantum computing industry. We are witnessing the moment we move from the era of fabless science to the age of industrial dominance.
So to really get our heads around this deal, we're going to break it down into 6 key parts. We'll kick things off by framing this as quantum's Intel moment. Then we'll look at the massive financial firepower that's making it all possible. From there, we'll unpack the core strategy, uncover a hidden national security advantage, run a much-needed reality check on the risks, and finally deliver our verdict on what the road ahead looks like. All right, first up, let's talk about why we're calling this quantum's Intel moment. This right here. This is the critical pivot point for the whole industry. It's the shift from tinkering in the lab to churning things out in a factory. So on January 26th, IonQ announced it was buying SkyWater for about $1.8 billion. But look, that number, as big as it is, really isn't the main story. What it represents is the real headline. This is the starting gun for the industrialization of quantum computing. The game is no longer about who can build the most elegant little device in a university lab. It's about who can actually manufacture it at scale. Which brings us right to our second point, the financial war chest. Because, to pull off a pivot this huge, you need an immense amount of capital. In a hardware race like this, money isn't just an advantage, it's pretty much the ultimate weapon. And this deal? It completely redraws the competitive map. I mean, just look at this table. You see IonQ, post-deal, sitting on over $2.5 billion in cash, with full ownership of its own manufacturing and the highest level of DoD security clearance. This just creates a massive, massive gap between them and their direct rivals. And this bar chart tells the story in the bluntest way possible. In hardware manufacturing, cash is oxygen. IonQ now has a massive supply, giving them a really long runway to innovate, to iterate, and even to absorb some setbacks. Smaller players, on the other hand, are operating with way less breathing room, and that can be absolutely fatal when things get tough. Now, this financial position wasn't some happy accident. Oh no, IonQ strategically raised $3.5 billion back in late 2025 because they knew a major M&A event was on the horizon. After putting about $770 million in cash toward this deal, they're left with this enormous war chest that's designed to fund everything all the way through that critical 2028 industry inflection point. So all this capital is fueling a very specific plan, which brings us to Section 3, the core strategy. When you boil it all down, IonQ is using its financial muscle to buy the one thing you can't create out of thin air: time. And they're doing it by shifting from a fabless model to becoming completely vertically integrated. Let's just look at the old way versus the new way. As a fabless company, IonQ was basically just another customer waiting in a long line at some other company's factory, often not even a priority. But now, as an integrated device manufacturer, an IDM, they own the factory. Their R&D team has a direct priority pass right to the manufacturing floor. They control the whole process from beginning to end. And this just brilliantly shows the impact of having that control. The time it takes to go from a design to a physical chip just plummets, from 9 months all the way down to 2. That's a 78% reduction. Think about what that means. While a rival can maybe fail, learn, and try again once a year, IonQ can now run that entire cycle almost 4.5 times in that same period. In this race, the speed of learning is the speed of dominance. This kind of speed-up is absolutely crucial for mastering a really complex process called heterogeneous integration. It sounds fancy, but you can just think of it like building a single, powerful superchip by combining a bunch of smaller, specialized chips, one for controls, another for optics, and of course the quantum ion trap itself, all into one tiny, efficient package. It's like building a high-performance engine by perfectly fitting together custom parts. And this is where the acquisition is just so clever. SkyWater's facility down in Florida happens to be one of the best places in the world for exactly this kind of advanced packaging. You can see it in the diagram. They have this unique capability to layer and integrate all these different critical parts inside the high vacuum environment that these trapped ion quantum computers need to even function. But this technical skill unlocks another incredibly powerful advantage that a lot of people have overlooked, and that brings us to Section 4. The creation of a deep, defensible national security moat. The key to this moat is symbolized by that little lock icon you see on the screen. SkyWater has this highly coveted status of a DMEA Category 1A trusted foundry.
So what does that actually mean? Well, it's the absolute highest level of security clearance you can get from the Department of Defense. It certifies SkyWater to produce classified top-secret microelectronics for the most sensitive national security applications. We're talking missiles, spy satellites, intelligence hardware, the whole shebang. For IonQ, this gives them exclusive access to contracts from the DoD, the CIA, and the NSA that unaccredited competitors just can't even touch. This deal really transforms IonQ into a pan-American industrial complex with a secure domestic end-to-end supply chain. With facilities now in Minnesota, Texas, and Florida, they are perfectly positioned to capture future CHIPS Act funding and really cement their role as a strategic national asset in the tech race with China. Of course, a deal this big is never a guaranteed success. To be objective, we have to run a reality check here and acknowledge that pretty significant risks involved. So the most significant risks are really twofold. First, there's cultural integration. Can you really merge the academic, research-driven culture of quantum physicists with the super rigorous, process-driven culture of factory engineers? It's been called the Intel Challenge for a reason. Second is the CapEx burden. Owning your own factories is capital-intensive. IonQ now has to take on all the depreciation and maintenance costs that it used to just outsource.
So, after weighing those risks against all the advantages, what's our final verdict? Let's turn to the road ahead. We believe that despite the challenges, the strategic gains from this deal are going to massively accelerate IonQ's path to industrial dominance.
And you can see the direct result right here on this chart. Key technical milestones, like hitting 200,000 physical qubits and 8,000 error-corrected logical qubits, are being pulled forward by a full 24 months, from 2030 all the way down to 2028. This is the tangible return on their strategic investment. Ultimately, this acquisition successfully transitions IonQ from a company that was valued on the dreams of scientific research to one that's going to be valued on industrial reality and execution. The path from integration in 2026 to potential industrial dominance by 2028 is now clear and, frankly, credible. They've transformed themselves from a science project into a full-on industrial powerhouse. And this brings us to the single most important takeaway from our analysis. Through this bold, strategic acquisition, IonQ has bought the most valuable and irreplaceable commodity in the entire quantum race: time.
Thanks for watching. Please like and subscribe.